What I'd like to do in this video is just go back over a little bit of basic differentiation rules and then use basic differentiation to find the slope of a function at a given point. First, let's be reminded of some of these, the 2 or 3 rules that we've worked on so far. The constant multiple rule is one of them. It says that d dx of c of f of x is equal to c times f prime at x, and we're going to go over what that means in just a second, but it looks kind of terrible, but there's that. The second one is the power rule, and the power rule says this. The power rule says that the derivative of x to the n power is equal to n times x to the n minus 1 power. So the reason that I changed the color of these n values is that this n is this one and this one. So what happened was this n came down, was multiplied by what was in the front here, and then the exponent was decremented by 1. So let's try to apply this a little bit. I think this is going to get really easy. So let's just do this. Let's find the slope of the graph of f of x. So find the slope of the graph of f of x equals 2x to the 4th power when, I don't know, when a, x equals 1, b, when x equals 0, and c, when x equals, I don't know, negative 1. And all these numbers are just arbitrary. So look, I guess here's the first thing. We want to find the slope of our graph. This looks a little bit parabolic, right? It's going to have a little bit of a shape like this. We want to find the slope of this graph. First thing we're going to do is we want to find the general derivative, the general slope. So what we're going to do is we're going to use some of our rules, and we're going to say, well, okay, f of x is equal to 2x to the 4th power, right? So the way we're going to differentiate this, so f prime at x, the slope of this function, f prime at x, is equal to, right? And this is what we're going to do here. We're just going to use this as our model over here. We're going to do 4 times this 2 right here, right? And then after we do that, then we're going to decrement this by 1. So minus 1. Minus 1. So this, what's happening here is that this c right here, is this 2 right here. So 4 times 2 is 8, right? So 8x. After we've done that, then we decrease the exponential value of the variable by 1. So 4 minus 1 is 3. So there's our general, right? This is our general derivative, right? Or general slope. So now what we're being asked to do is find specific slopes. So we're being asked, given this function right here, what's the slope of this function when x is 1? So how would we figure that out? Well, when x is 1, so what we want to know is what is the slope when x is 1? So we want f prime at 1, where this one is this one. Then we're going to go to the derivative function, which is this function here. This is our derivative function, right? And we're going to plug it in here. And then we're just going to start working with that. And we're going to say the derivative function is 8. 8. We want to know what the slope is when at 1. So 1 and to the 3rd power, right? So f prime at 1 is equal to 8. So the slope of f of x at x equals 1 is 8. That's not 8 factorial, it's just 8. Okay? So how do we do the rest? Exactly the same way. We'll take, right, we're going to use this now on this. So we want to know, the question now is, what is f prime at 0? The question being asked at f prime at 0 is, what is the slope of this function when x is 0? If you plug this back into this equation, you're going to get the height of f of x. You know what? We're not interested in the height of f of x. We're interested in the slope of f of x. And it is f prime at 0 is 2 times, no it's not. No it's not. It's 8 times 0 cubed, and 0 cubed is 0. 8 times 0 is 0. Okay? See the pattern here? So that answers this question. The slope of f of x at x equals 0 is 0. It's not, right? Turns out when x is 0, the slope is 0 here. When x was 1, the slope is 8. So they're not necessarily correlated. And then the last one was this one, was -1, right? We want to know. Sorry. Now we're going to work on this one. What are we going to do? We're going to plug it in here. Do the same thing. So the question now becomes, what is the slope? F prime at -1 is equal to 8 times -1 to the third power. Well, -1 to the third power is -1, so we have 8 times -1 equals -8. We okay with this? And if we look at the function, if we go back and look at the function, what if I already had it on the next screen? If I just hit this button and we just go right to that thing, then I would have been a genius, but it didn't happen, did it? So here is that function, and check this out. See, we just check our math. This is a TI Inspire CAS calculator. A new one out is the CX, and they're real good, but this is, I just used the graphing function here. So I graphed, this red function is our function, 2x to the fourth power. I found the derivative, right? The derivative is a function also, right? And we were interested in what is the slope of f of x when x equaled these had these values. So, I wonder if I can make that work. Whoops. You can do it, Charlie. There it is right there. So we want to know what is the slope of f of x when f of x, well look, when x is -1, the height of f of x is 2, but the slope is -8. And look, over here at -1, look how steep this thing is. So it's saying that the steepness is -8 right here. And then we said, well, what's the slope of this function, right? The red is the function, the green is the derivative. What's the slope of f of x when x is 0? We'll go over to the slope function, and indeed it's 0. And look, if you look at the red function right here, it's flat here. It's changing directions from negative slope to positive slope, and as it changes, it transforms from negative slope to positive, so it has to go through a slope of 0. And then we go to when x is 1, and we say when x is 1, the slope is 8. Well, look at this. The slope is 1, 2, 3, 4, 5, 6, 7, 8. It's right here. This is the height of the green is the slope of the red. And if you look at here, the slope right here, if we could draw a point right here, and we could draw a point right here. What we're asking ourselves, the question we're asking ourselves is, what's the slope of this tangent line? So what we're using is something called a tangent line approximation. And if you don't mind pretending with me that this thing only touched the red curve just the one time at this place right here. And what I'm saying to you is that this tangent line approximation, the slope of this blue dotted line is a slope of 8. So here is the slope. Here's the x value. Here's the slope. Here's the x value. Here's its slope. Here's the x value. Here's its slope. Remembering that this is the derivative function. All right? So I hope that was really helpful. I mean, this is something that we can do. And if you want to know, at this level of calculus, this is how this math is applied. So keep up the good work. This is very, very doable. You're going to be great at calculus.